Okay, these are the problems that we are going to solve for lesson 26 about the exponential functions. And we are going to review what it means a function, what it means the inverse of the function. So in this case, let's go to the next page. Let's go to review one very basic idea. A function is like something that transforms things into another thing. For example, imagine that you measure with the time t, you measure your height. Maybe when you were 1 year old, your measure is zero point 0.3. Maybe when you were 2 years old, your height was zero point 0.4 meters. Maybe when you are 20 years, your height will be, let's say, 1.60 meters. So the function, what it does, it takes the time t and convert the 1 into zero point 0.3, the 2 into zero point 0.4, and the 20 into 1.6 meters. So this is what it does, the function f. F of x, in this case, is f of t. It converted into an h. So the function is h equal f of t. And the function may be this one or whatever. Of course, it needs to pass the vertical test because have no sense to have two heights at the same times. You need to cross one time. Okay, this is a function. So imagine you have the x and you apply, for example, to the x, you apply the function log of x. So I will produce a point y which is log of x. Let's say that the point that I choose is the point x equal e. So I will apply the function log to the point x and I will obtain another point. What is the point that I will obtain? Well, log of e is 1. So I will obtain the point 1. Now I will talk about the inverse function. The inverse function will do the opposite of what the function is doing. The log is putting the e on 1. And the inverse function, that is the e to the x, will put the 1 into the e. What is the inverse function? E to the x. Why? Because if I take the point 1, e to the 1 will be converted into e. So the inverse function will work like this. If f of x is a function, you will find the y. Now, if g is the inverse function, or f minus 1 is the inverse function, f minus 1 of y will be the x, or f minus 1 of y of f of x will be the x. This is what we are doing. In this way, the logarithm of x and the e to the x, they are inverse function. Imagine, for example, I take the number 1 and I apply the function e to the x. E to the x takes the number 1 and convert it into the number e to the 1. Now, the function log, natural log of x, takes the number e to the 1 and convert it into 1 because the natural logarithm of e is 1. So you need to know these two graphs by memory. This is the graph of the logarithm of the function of log of x. This is the graph of log of x. When the log of x is 0, x equal 1. When x is e, the log of e is 1. When x is e squared, the log of x is 2. And the other graph that you need to know is the symmetrical graph respect to the y equal x. Y equal x is this graph, and the function e to the x does like this. The point, this point is the point 1, 0, and it will appear in the inverse function as the point 0, 1, which is this one, 0, 1. And the point e1 will appear in the inverse function as the point 1a. 1a is here. 1, 2.7. So the graph of e to the x is something like this. You need to know by memory this graph, e to the x and log of x. Now let's go to do the problems. Now the problems say, the first problem, if e to the x is equal 12, who is x? Who is the number x? When I do e to the x, I will obtain the 12. So you will apply the natural log to this equation. So if I apply the natural logs to both sides of the equation, I will obtain the natural log. Natural log means that the base is e. The natural log of e to the x equals the natural log of 12. But what is the natural log of e to the x? Because natural log is the inverse function of e to the x, this will be x. So x is natural log of 12, and the problem is solved. Let's go to the other problem. How you will solve this equation? So I will use the inverse. How I will use the inverse? I will imagine that the inverse, I will know that the inverse function to natural log of x is e to the something, e to the something. So I will do e to the something here, and I will do e to the something here. So the equation will read e to the log of x equal e to the 2. And this will allow me to solve for x. Why? Because e to the log of x is nothing like x. So x is equal e squared. And e squared is something like 2.71 irrational number, infinity digits squared. So the x is e squared, and remember that the definition of the number e is that e is the limit when x tends to infinity of 1 plus 1 divided by x raised to the power x. If you do this number, if you do 1 plus 1 divided by 1 million, 10 to the 6, raised to 10 to the 6, this will not go to any infinity or 1. This will go next to 2.71, whatever. If you take the number 1 plus 1 divided by 10 to the 10, 10 to the 10 is a big number. Raise 10 to the 10, this will be also 2, next to e, 2.7111, whatever. This is approximate. In the limit will converge to a number that is the number e. The number e is an irrational number. It cannot be written like the quotient of two integers. E is irrational. Okay, next problem. Now problem 3. If log of a square root of x plus 1 is square root of x plus 2 equal 1, who is x? So maybe I will write this like this. Log of x plus 2 raised to the 1/2 equal 1. Now I will say if I apply to this number the log of this function, log of x plus 2 raised to the 1/2, if I apply the function e to the log of x and e to the 1, I will obtain e to the 1 in the right side of the equation and e to the log of x plus 2 1/2. And what is e to the log of the number? Is the number. So it's x plus 2 1/2. So x plus 2 1/2 is e. But I want to know who is x. So I will elevate the square and will be e squared. If I raise to the 2 power, I will have this equation. So the x is now being solved like e squared minus 2. So the problem is solved. What it means that this is the solution. You take the x, you plug in here, and you obtain 1. Well, let's go to do it. The log of a square root, of x plus 2, when x is equal to e squared minus 2 plus 2, this is equal to the log of the square root of e squared, which is equal to the log of e, which is 1. Oh, it's true. Here it says 1. Okay. I hope it's clear. Let's go to the next problem. Okay, in this problem we need to find the derivative of the function e raised to a square root of x. So when we have e to the u, the function e to the u, the derivative respect to the u of e to the u is equal e to the u. Now the derivative respect to the x of e to the u that depend on x is e to the u by the derivative of u prime of x. So in this case we have u of x equal x 1/2. So the derivative of u respect to the x is 1/2 x raised to the power 1/2 minus 1, which is minus 1/2. So this is the derivative of u respect to the x. So the derivative respect to the x of e square root of x is e to the square root of x by the derivative of f of x, that is square root of x, 1/2 x minus 1/2. So what I have applied is the derivative respect to the x of e to the f of x equal e to the f of x equal by f prime of x. If you want to name f of x like u, it's the same thing. So this is the derivative. Now we are going to find the derivative of this expression. This expression is the quotient of two functions. When you have f of x equal g of x divided by h of x, what is the derivative of f of x? The derivative of f with respect to x, or f prime of x, is the derivative of the numerator by the denominator minus the numerator multiplied by the derivative of the denominator divided by the denominator square. Okay, in this case, g of x is the numerator. What is the numerator? E of x is e to the x plus 1. And the denominator is h of x, which is e to the x minus 1. And g prime of x, is e to the x plus the derivative of 1, which is 0. And the derivative h prime of x is e to the x plus the derivative of minus 1 is a constant, doesn't change, so the derivative is 0. So f prime of x will be the derivative. So I follow my equation for the derivative of the quotient of two functions. It's the derivative of g. The derivative of g is e to the x by h to the x. hx is e to the x minus 1 minus g of x e to the x plus 1. The numerator multiplied by the derivative of the denominator, which is e to the x, divide by the denominator square. The denominator is e to the x minus 1 square. Now the problem is already solved, but we need to work a little bit and to make a little bit of algebra. Let's go to make a little bit of algebra here. So e to the x multiplied by e to the x. What is e to the x multiplied by e to the x? Well, remember that x to the n multiplied by x to the n is x to the n plus n. In this case, is confusing. So let's go, it's confusing the a. So let me erase here. A to the n multiplied by a to the n is a to the n plus m. In this case, the a is the e, the 2.71, and the n is the x. Multiplied by e, the a is e, and the n is x. I'm doing this multiplication. So e to the x multiplied by e to the x is e to the 2x. So let's go to do the algebra. So the algebra will be like this. This, the first multiplication will produce e to the 2x. The second multiplication, when you do the distributive property here, will produce minus e to the x. So this will be e to the 2x minus e to the x. So this is the first factor. Now I'm going to multiply this also minus, open parenthesis, e to the 2x when I multiply this by this, plus e to the x. Now, minus e to the x, and minus e to the x is minus 2 times e to the, divide by e to the x minus 1 multiplied by e to the x minus 1. So let's go to do it. Let's go to do a little bit more of algebra. E to the 2x minus the e to the 2x, this will cancel. And I will have minus e to the x 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 divided by e to the x minus 1 square. So it will be minus 2 times e to the x divided by e to the x minus 1 square. So this is the final result. This is the final result, okay? Okay, now we find the derivative of this function, f of x equal e to the x sine of x plus cosine of x. So f of x is the product of two functions. It's the product of g of x with h of x, where g of x is e to the x, and h of x is sine of x plus cosine of x. Okay, and what is the derivative of the product? The derivative of the product is the derivative of the first by the second plus the first by the derivative of the second. In this case, because g of x is e to the x, g prime of x is e to the x. Remember, the function e to the x is the only function whose derivative is equal to the same function. And h prime of x, the derivative of the sine is cosine of x. And the derivative of the cosine of x is minus sine of x. So this is h prime of x. So what is the derivative of this function? Or this function, what is the derivative of this function? The derivative of e to the x, f of x is e to the x sine of x plus cosine of x. The derivative f prime of x is the derivative of the first, a to the x. By the second is sine of x plus cosine of x, plus the first, e to the x, by the derivative of the second, cosine of x minus sine of x. So it will be e to the x sine of x plus e to the x cosine of x, but e to the x sine of x, this term, will cancel with this term. So it will be e to the x cosine of x plus e to the x plus e to the x cosine of x. So it will be 2 times e to the x cosine of x. Okay, and this is the result. Of course, you can do the same problem in different way. You can say, for example, if f of x is equal e to the x sine of x plus cosine of x, that means that f of x is e to the x sine of x plus e to the x cosine of x. And you can do the derivative of the sum of two functions. But there are a product here, and now it's longer. So it will be the derivative f prime of x will be the derivative of the first, e to the x, by the second, sine of x, plus the first, e to the x, by the derivative of sine of x, cosine of x. Perfect. I have made the derivative of the first term. Let's go to make the derivative of the second term. It will be the derivative of the first, e to the x, by the second, cosine of x, plus the first by the derivative of cosine of x, which is minus sine of x. And now, what is f prime of x? As you see, again, there should be a cancellation between this term, e to the x, and this term. So the result will be, again, f prime of 2 times e to the x cosine of x, these two. And the problem is solved. Let's go to the next one. So this problem is you have a function that is y equal x multiplied by e to the x minus e to the x. So the function y of x is the function e to the x multiplied by x minus 1. This is the function. And for sure, it will have a slope at x equal 1. It say at the point x equal 1, y equals 0. Is y equal 0 when x equal 1? Let's go to check. When x equal 1 is e to the 1, and 1 minus 1 is 0, 0 by e to the 1 is 0. So I don't need this information that y equals 0. I want to find the slope of x equal 1. Once that I find the slope, the derivative of y respect to the x at x equal 1, let's call it m, the tangent line will be y equal y0 plus m by x minus x0, being the point x0, y0, the point 1, 0. So let's go to do it. So what is the derivative of y respect to x? I need to know the derivative of y respect to x at the point x equal 1. The derivative of y respect to the x is the derivative of y respect to the x is the derivative of the first by the second plus the first by the derivative of the second, which is 1. So this will be e to the x multiplied by x minus e to the x plus e to the x will be 0. So the derivative of y respect to the x evaluate at the point x equal 1 will be e to the 1 by 1. So it will be e. This is the derivative. So what is I have the curve, whatever it is, I have the point is 1, 0, so I have the curve, let me put it the curve like this, whatever. This is the point 1, 0, and the tangent line, what is the equation of this line, of the tangent line? The equation of this line is y equal y equal y0, which is 0, plus m, which is e, multiplied by x minus x0, which is 0. So the equation is y equal x multiplied by e. It sounds logical. Let me see if I made a mistake. I don't think I made a mistake. Oh, yes, I made a mistake because x0 is 1. So let me correct. So the equation of the tangent line, this y is not this y. This y is the y that represents the tangent line. So it's a different y. So how I will call it? Well, you know that it's a different line. It will be 0, y0 plus e multiplied by x minus 1, or if you prefer, e times x minus 1 is the rectilinear line that passes through the point 1, 0 and is tangent to the line. Good, this is the answer. Now let's go to do the problem number 8, where it says find the integral x squared e to the x cubed ddx. As you can see here, x cubed, and the derivative of x cubed is 3x squared. The 3 is missing, but we will find how to place the 3 there to find this. So let's go to do it. Let's go to name u equal x cubed. What happens if we name u equal x cubed? So the derivative of u respect to x will be 3x squared. So du equal 3x squared ddx. But x squared ddx is sitting down in front of you, and here is x squared ddx. So I can rewrite this equation in the following way. The integral of x squared e raised to the x cubed ddx will be, what is x squared ddx? X squared ddx is ddu divided by 3. ddu divided by 3. And what is e to the x cubed? Is e to the u. So this is 1/3 of the integral of e to the u ddu. So this is 1/3 of e to the u, because the integral is e to the u. So it's 1/3 e to the u, but e to the u is e to the x cubed. So this will be the result. So we may say, okay, if I make the derivative of this function, Shall I obtain this function? Yes, let's go to do it. The derivative respect to the x of 1/3 of e to the x cubed is 1/3 e to the x cubed multiplied by the derivative of x cubed, which is 3 times x squared. Now the 3 will cancel with the 3, and I will obtain the integral x squared e to the x cubed. So I have checked that I have not made any mistake. So let's go to do this problem. It's the integral of e minus e raised to minus x 1 plus e minus x. So if I place u equal 1 plus e minus x, d du, or the derivative of u respect to the x, will be e minus x by the derivative of x, which is minus 1. So d du will be minus e minus x by d dx. But e minus x d dx is here. So the integral will be the integral of e minus x divided by 1 plus e minus x v dx equal the integral of 1 divided by 1 plus e minus x by e minus x d dx equal the integral of 1 divided by e minus x, 1 divided by u, by d du, almost d du, minus d du, minus d du. So it would be minus the integral of 1 divided by u d du. Do I know how to do this integral? The integral is log of u, log of u. So what is the integral? The integral is equal the log of u, the log of 1 plus e minus x. So let's go to make the derivative to check if this result is okay. If I make the derivative of the logs of 1 plus e minus x, the derivative of the log of 1 minus x will be the integral. Let's go to check it. So let's go to check it. So the derivative respect to x of the log of 1 plus e minus x is equal 1 divided by the function by the derivative of the function e minus x. So is this the integral? Let's go to see. E minus x divided by 1, e minus x divided by 1 plus e minus x. Let's go to see if this is the integral. Yes, e minus x. This is the integral. So it's correct. What I did is correct. Okay, let's go to the next question. The next question is find the definite integral. Oh, sorry. You need to add a c in the indefinite integral. I'm sorry that I forgot to add it. So let's go to do this integral, the integral from 3 to 4, from x equal 3 to x equal 4 of e raised to the power 3 minus x d dx. So we name u like 3 minus x. So d du is minus d dx. Okay, well, the derivative of u respect to the x is 0 minus 1. The derivative of 3 is 0. The derivative of x is 1. With the minus sign is minus 1. So d du is minus d dx. So I have d du here, and I have the integral from x equal 3 to x equals 4. So when x equals 3, u equals 0. When x equals 4, u equals minus 1, or 3 minus 4. It is minus 1. So now I'm going to write the integral in terms of the u. So it will be the integral from u equals 0 to u equals minus 1 of e to the u by ddx, but ddx is minus ddu by ddu with minus sign. So this is the integral from u equal 1 to u equals 0, from u equal 0 to minus 1 with the minus sign is the integral from u equal minus 1 to u equals 0. Of what? Of e to the u by ddu. So this is e to the u. Evaluate between u equal minus 1 and u equals 0. So it will be e minus 1 minus e raised to the power 0. So it will be 1 divided by e minus 1 e to the 0 is 1. So this is the solution. The solution, but I made a mistake. I'm sorry. Let's go to correct. Is e evaluate of the upper points is e to the 0 minus e to the minus 1. And it's 1, e to the 0 is 1 minus e minus 1. So it's 1 minus 1 divided by e. Sorry that I did. I have is g of b, the upper limit, minus g of a. Sorry, I did it reverse. So this is the result. 1 minus 1 divided by e. So let's go to make this integral. Is the integral of e raised to the 3 divided by x, divided by x squared. So the logical thing is to say that u of x equals 3 divided by x. Why? Because if you put u of x equals 3 divided by x, what will happen? What will happen? Let's go to do it. If I name u equals 3 divided by x, v du divided by ddx is minus 3 divided by x squared. I might have the 1 divided by x squared on the denominator. So I have ddu. So ddu will be minus 3 times divided by x squared ddx. So let's go to write the integral. The integral from x equal 1 to x equal 3 of e raised to the power 3 divided by x divided by x squared ddx, this is the integral. E to the u. Now, x squared by ddx is here. X squared by ddx is here. So minus ddu divided by 3 is 1 divided by x squared by ddx. So I will put ddx divided by x squared as minus ddu divided by 3. So now the integral will be minus 1/3 by the integral of e to the u by ddu. But pay attention that x equal 1 means that because u equals 3 divided by x, means that the lower limit is 3 divided by 1. When x equals 3, u equals 3 divided by x, so the upper limit is 3 divided by 3, which is 1. So the limit of integration is from u equals 3 to u equal 1. So I may change the sign 1/3 and put from u equal 1 to u equal 3 of e to the u d du. And the integral of e to the u d du is very easy, is e to the u. Or evaluate between u equal 1 and u equal 3. So it will be equal to 1/3 e3 minus e1, or 1/3 e that multiply e squared minus 1. And this is the final result. Now we do problem 12. It's a use implicit differentiation to find the derivative of y respect to x. Y of x is not explicit done. It's not explicitly expressed. We need to find the derivative of y respect to the x. So the equation is that x by e to the y minus 10x plus 3y equals 0. So let's go to make the derivative respect to the x in both sides of the equation. The derivative of the 0 is 0 because it's a constant function. And the derivative of x multiplied by e to the y is the product of two functions. Is the derivative of the first 1 by the second without making the derivative, plus the first by the derivative of e to the y. The derivative of e to the y is e to the y by the derivative of y with respect to the x. And now this is what I have to find, the derivative of y respect to x. Minus 10 plus 3 by the derivative of y respect to the x. Now I have, and this is equal to 0. This is equal to 0. Now let's go to play a little bit. So let's go to join the terms that have dy ddx. Dy ddx have x by e to the y and have a 3. So I have used these two terms, this and this one. Okay, so plus equal, so minus e to the y plus 10. I have sent this term to the other side and this term to the other side. So now I have dy ddx. So dy ddx is 10 minus e to the y divided by x e to the y plus 3. Now, this is the slope in implicit differentiation. The slope is not a function of x. It's a function of x and y. It depends on the point x, y. So this is the derivative of x to the y. The derivative of y respect to x. Can I make this to look only as a function of x? Let me think. If I have the term, no, I cannot do it. No, I cannot do it. Sorry. Now we need to practice the second derivative of this function, which is f of x is 3 plus 2x multiplied by e minus 3x. So I can consider like the product of two functions, this function and this function. So the derivative of x respect to the x is the derivative of the first, which is 2, by the second, e minus 3x, plus the first, 3 plus 2x, by the derivative of the second. The derivative of the second is minus 3 e raised to minus 3x. So now let me try to compress this a little bit. So it will be 2 times e minus 3x plus 3 by 3 is minus 9, minus 9 times e minus 3x. So it's this by this, minus 9 minus 6 times x e minus 3x. So this will be 2 times minus 7 times e minus 3x minus 6 times x by e minus 3x. So it will be e minus 3x that multiply minus 7 minus 6x. Aha! And now I have the derivative of x with respect to the x. Now I have to do the second derivative. So the second derivative will be, again, to do the derivative of this expression. So we practice. The second derivative of s with respect to x will be the derivative of the first, minus 3 by e minus 3x, by the first, minus 7 minus 6x, plus the first by the derivative of the second. The derivative by the second is minus 6. Now, if I do a little bit of algebra, will be minus 21 e minus 3x plus 6 by 3 is 18 x e minus 3x minus 6 times e minus 3x. So minus 21 minus 6 is minus 27. So it will be minus 27 e minus 3x plus 18 times x minus 3x. And this is the final result for the second derivative. But I think I made a mistake. And the mistake is here. Here is the mistake. Minus is plus. So this is plus 21x plus 18x minus 6x. So the result will not be the one that I said. 21 minus 6 is 15. Is plus 15 e to the minus 3x plus 18x e minus 3x. And this is the final result. Well, you can compress the result by factoring e minus 3x that multiply 15 plus 18 times x. This is the final result. Okay, let's go to the next one. Oh, sorry, there is no next one. This is the last one. Okay, I'll see you soon.